The objective here is to identify appropriate situations in a program for using a loop. So as we have developed as programmers, we have focused on the process of breaking down large tasks into smaller pieces and assigning each piece a function. When we break down a large task, often we find that some portion of the task needs to be repeated many times. As programmers, we would simply call the same function many times. So over here on the right is a great way to visualize the need for a loop. You have some sort of program initialized and you'll go through a process, and if there's a moment where you'll need to use a loop, then you can create one off to the side there, and it'll loop until your needs are met and then continue on with the program. Random numbers are a perfect example of this. So random numbers are also used much more in this lesson as an effective way to experiment with loops. Creating some randomly generated output with each iteration of the loop is good visual feedback that the loop is running the way you expect. It also helps you explore the ranges of possible outputs, which tells you more about what your program can and cannot do. So your think, write, share here is what is the benefit of using randomly generated numbers. So here's a really simplistic example of what I'm talking about. If you're in the bash shell, you can use $random, and that'll give you a pseudo-random number between 0 and 32,000, basically. And so with that number, you can initialize something. So here is our loop for, and then inside here are the parameters. This initializes the test. And this is the test if x is less than 100. And as long as x is less than 100, it will increment by 1. So once this begins, it'll start at 0 and go all the way to 99. The for loop, which is that, it says for in the beginning, so the for loop in JavaScript and many other programming languages is designed to be used for both simple and sophisticated programming tasks. So thus it has a lot of syntax to it that will be explained in the future. For now, in this lesson, the block-based form of the loop exposes students to effectively using a simple repeat loop, and it only lets you change a number that dictates how many times the loop repeats. So think, write, share here. How will we know the number of times a loop should repeat? Feel free to use a real-world example. Also feel free to go back here and use some code, pseudocode from this example. Important points to draw out are related to when to use a function, when to use a loop. While you can get code to function similarly with a function or a loop, the general rule of thumb is this. Write a function when you have a piece of code or a procedure that you might reuse in other places in your program. As long as you remember that that's the purpose of the function, then you should be fine. Think, write, share. When should you use a function? Couple examples to wrap your mind around. A function might also help you encapsulate a solution to a common problem in one place that you can call on repeatedly with different inputs. The example here is the draw square function. If you want different sizes, there you go. Writing a function is often more of a design decision. You're trying to encapsulate and abstract details so you think about other parts of a larger program. In summary, what that's saying is when you need an abstraction, that's when you're using a function. Essentially, the purpose of an abstraction is getting rid of details so you don't get distracted. And that's really all there is to it. Write a loop when there's something you need to do over and over again, and it doesn't make sense to split it up anymore. Writing a loop is more of an algorithmic decision. You actually just need a repetitious behavior to solve a problem. For example, we don't want to manually call functions many times in a row, so if you're calling the same function many times in a row, that's the time to use a loop. Think, write, share. When should you write a loop? Alright, so here we have an opportunity to put these concepts into practice, so if you could go to that link, I'll meet you there. Alright, so here we are on code.org, and we're looking at puzzle 3, Introduction to Loops. It says a loop is a block of code that is repeated or looped through in a program. You'll be creating a loop using the for loop block. So we'll start by experimenting with a program similar to what you saw in the video, and that video will be right below this video in Canvas. So basically all you're doing is following these simple directions in the beginning, and I like to turn my text on here and just experiment. You have plenty of time to do that in class. Excellent work there. So we're going to wrap up this lesson. I just want to do a quick check for understanding. Looking at this code, what do you think this does? And in closing, a loop is a programming construct that repeats a group of commands. Iteration is loop by another name, the repetition of a statement, process, or procedure. A for loop is a particular kind of looping construct provided in many languages. Typically, a for loop defines a counting variable that is checked and incremented on each iteration in order to loop a specific number of times. Your DOL for the day is what kinds of circumstances would lead you to writing a function versus using a loop.